Welcome to Embedded Projects. Today we are going to see about a interesting project, that is drowsiness detection alert system using Raspberry Pi board. So let us see the project components first. So this is the Raspberry Pi board. So here we are using the Raspberry Pi 3P Plus model for the purpose of image processing and controlling the other components. GSM modem, GPS with its antenna, patch antenna, motor driver board and voltage regulator, ultrasonic sensor, buzzer, active buzzer, battery and relay setup for controlling the pump, DC motor and wheel, and web camera. So this is the total setup of the project. So by using this project we can control the vehicle based on the drowsiness of driver. So initially this project will get the data from the camera, that is the drowsiness data from the camera, and process with the image processing using the pre-trained data set, and accordingly based on the EAR value it will control the vehicle. So after getting the data from the webcam, initially it will try to alert the driver by using the buzzer, so using the counter value. So after some time it will turn on the relay and flush the water or spray the water in the face of the driver to alert him. And then if even after alerting with the water, if the driver is not alert, then it will automatically send the SMS and mail to the car owner with the location that we got from the GPS device. So this is how the entire system works, and also it additionally controls the vehicle based on the ultrasonic value. So if there is no vehicle in front of the car, it automatically slow the speed of the vehicle and stop the vehicle gradually. So this is how the entire system works. So now let us test the project. So for testing the system we need to connect the Raspberry board in the remote view. So by using the VNC we can SSH the Raspberry Pi and get the desktop of the Raspberry Pi in our device like mobile or laptop. So here I am using the tab for getting the desktop. So you can see I have entered the IP address of the Raspberry Pi and I am just creating the system, and I can directly connect to the Pi. So we need to enter the username and password of the Pi. So after entering the username and password of the Pi, it will connect to the Raspberry Pi and show the desktop of the Raspberry Pi in the device to which you are connected. So here I am using the tab. You can also use the mobile or laptop. So we need to run the project first. So for running the project, I am just opening the terminal. I am just opening the terminal window. So now the terminal window is open, and then I have to enter the command for opening. So I can enter the command, either I can enter the command or I can choose the command that is entered in the previous session by using the up down arrows. So by using the up arrow I can choose the command. So I am just choosing the command for running the project. So initially we can see the code. So for seeing the code we have to enter the command sudo idle3 project.py and then enter. So it will open the idle window. Idle window consists of the code, Python code for operating the project. So this is the project window, you can see. So this is the code we are using to control. So now we can run the project. I am just closing the idle window and I am going to enter the run command, that is the Python command. So already it is given in the history of terminal. So from the history I am just retrieving the command and executing the command. So after executing the command, initially it will load the landmark data, that is the facial landmark data. So it will take some time. So after loading the landmark data, it will give the beep sound and we can start the project for testing. So you can see it's showing loading facial landmark predictor. So we need to wait for the beep sound. So now we got the beep sound. So now camera will be activated. So after the beep sound, the camera will be activated and we can give the face input to the camera. So you can see the activated camera screen here, driver monitor. So now we need to have our driver person for the testing. So now you can see the driver's image and also you can see the eye is being detected by using EAR and both left and right eye are detected. So now the driver is active. Since the driver is active, it will not do any actions. So now driver is going to sleep. So when the driver started sleeping, the count will be incremented and drowsiness alert will be generated. You can see the drowsiness alert. So buzzer alert is generated, and then you can also see it is trying to spray the water to the face of the driver, and then it will automatically as you can see since the driver is sleeping, it gives the drowsiness alert, and after that it will turn on and off the pump for the 3 times. And after turning on and off the pump for the 3 times, driver is still sleeping, so it automatically will send the SMS and mail, and before sending the SMS and mail, it will slow down the vehicle and then gradually it will stop the vehicle. So after stopping the vehicle, it will start sending the SMS to the owner or relative's number. So now the SMS is sent and then it will send the mail. So both the SMS and mail will be sent to the corresponding person. So this is how the entire system works.